Welcome back. Today's topic involves solving systems of equations using substitution. My approach to solving a system using substitution varies depending on how the system is written. In number 1, you'll notice that both equations are already written in slope-intercept form. This simplifies matters for us a bit because we already have y isolated in each equation, and if both equations equal y, they should be able to equal each other. So if I have this kind of situation right here, I can take this 4x plus 3 from my second equation and replace the y in the first equation with it. Now when I rewrite this, you'll see something magical happen. 4x plus 3 is being written instead of y, but then the rest of the equation gets written exactly as it appeared to begin with. So I still have my equal sign, I still have 6x and plus 1. Now I have a single equation that only has a single variable in it. Granted, there's an x variable in two different parts of the equation, but it's still an x variable. We don't have a y variable there anymore. This allows me to focus on solving for x so that then I can use that to go back and solve for y. Now when I'm trying to solve an equation that has x's on both sides of the equal sign, I always like to look for the coefficient, which is the number in front of x, that's the smallest. That allows me to deal with mostly positive numbers in my equation rather than negatives. I just don't really care for dealing with negative numbers if I don't have to. Kind of like negative people. Now in order to figure out which one's which, look at the 6 and look at the 4. 4 is smaller than 6, that's why this is the one that I'm going to eliminate. Now to eliminate a positive 4x, you want to do addition with subtraction. So if I try subtracting this 4x minus 4x equals 0, and that actually will eliminate from the problem. But to keep this balanced, I have to do the same thing to the other side. This equal sign means that both sides have to remain equal at all times. That means that equal operations have to be done on both sides at the same time. 4x minus 4x gives me 0. 0 plus 3 is just equal to 3. That's all that's left on that side. That's why we say that this has just been eliminated from the problem or canceled out of the problem. Carry down your equal sign. Don't forget to carry down every symbol as they should appear. And then 6x minus 4x equals 2x. And then carry down your plus 1. You aren't finished until you've written down the last piece of your equation. Now we have our x's grouped up on the right-hand side, and now I need my numbers without the variable grouped on the other side. So I need to remove any numbers without the variable from the right-hand side and get it to the left. Now the only number I have like that is this plus 1. When we're solving equations, we're trying to go in a reverse order of operations. Normal order of operations, when you know every number, is parentheses, then exponents, then multiplication or division, whichever one appears first as you read from left to right, and then addition or subtraction, whichever one occurs first, again, as you read from left to right. When you're solving, you do the opposite. You're climbing back up the order of operations, which means you start with any addition or subtraction that's not inside of parentheses. The only addition or subtraction that I have here is this plus 1, and you undo that with its opposite, which is why I'm going to be subtracting 1 from both sides. Now 1 minus 1 is 0, leaving me with only 2x on this side. I still have my equal sign, and then 3 minus 1 leaves me with 2. Only one step left to be able to finish solving this for x. Now remember that reverse order of operations? I've dealt with any addition or subtraction that was in the problem, but now I need to go back to multiplication or division. I have 2 times x, that's what 2x really means. It's a multiplication problem where you don't have to show the symbol because it's assumed based on the way that it's written. So I have 2 times x, I undo multiplication with division. That's why I'm going to divide by 2. I'm dividing by the number in front of x. That's always the number that you're dividing by. It's not some magical formula. You're literally undoing the number in front of x. So it's the number in front of x. You have to divide to both sides. 2 divided by 2 equals 1, and 1x is always just written as x. Mathematicians, we can be a little bit lazy. So when we have a shorter way of writing something, we take it. And that's why you often see our 1x is showing up as just x. And then 2 divided by 2 equals 1 also. That one I do have to write, because I do have to have a number on that side of the equal sign. Now you're not done yet. A solution to a system of equations is the point where the two lines intersect each other. And a point requires an x and a y. What I often like to tell students to do is to make sure that they write out the entire point by starting the point halfway through the problem. All I know right now is my x-coordinate, which is +1. In order to have a complete point, I still need this y variable, which means that I need to go back and do something with this 1 in one of my two equations in order to finish the problem. Now, it doesn't matter which equation you use. I'm just going to use the top one because, well, it's convenient. So I have y equals 6, and instead of writing x, I'm going to write parentheses and then +1. So I have this entire equation written out exactly as it appeared to begin with. But since this was 6 times x, if I want to replace x with a number, I'm going to put parentheses to make sure that I remember that this was multiplication. Now this 1 right here is going to go up into these parentheses. So now I have y equals 6 times 1, which is 6, plus 1, and 6 plus 1 equals 7. So the second half of my point is a coordinate of 7. And this point, if you were to test it into both of these equations, let's go ahead and do that verbally. Put 1 in place of x. 6 times 1 is 6, plus 1 is 7. That does equal the right number. 7 times 1 is 4. 4 plus 3 gives us 7, which is, again, the correct number. So this point is a solution in both of these equations. Solutions to lines are just the points that are actually on the line. So that's how you do substitution when you're dealing with equations that are already in slope-intercept form. But now we get to problems like number 2. What if they're not already in slope-intercept form? What do we do then? Well, the reason I said number 2 and number 3 are a little bit different from each other. Number 2 has this y variable without a coefficient, whereas in this equation, all of the variables have coefficients. Now, the convenient thing about finding a variable without a coefficient when you're dealing with substitution is that it's super easy to solve for. So I'm going to take this equation right here. I'm going to rewrite it down here. So negative 5x plus y equals negative 3. There really isn't a rhyme or reason to doing this except that it provides me with more space to actually show my work. And the more I show my work, the less likely I am to make mistakes, because even I make mistakes, as you're likely to see at some point in this video. Now, the reason I was adding 5x to both sides, if I want to isolate y, I want to remove what's on the same side as y. And a negative 5x is the same thing as a minus 5x. And you undo subtraction with addition, so if I add 5x to negative 5x, that cancels to 0, leaving me with y equals. Convenient, similar to this. Now on this side, because this has an x, I cannot combine these. I would need to know what x was first to complete the multiplication before I did the subtraction this negative 3 actually represents. A number's sign is just an operation symbol waiting for something to go in front of it. So this plus 5x, I'm going to write as a positive 5x. And then this negative 3, I'm going to write as negative 3 right after it, which shows up now as minus 3. That's what I mean by that symbol. It was just waiting for something to go in front of it to show that's actually subtraction. Now, once I have this, I'm going to rewrite this other equation underneath it so that we can remember our system. Because these two equations have to go together. And we're actually going to put them together. Now we know what y equals, and y is right here in the other equation. So I'm going to box in what y equals and draw an arrow to the variable that's equal to, the y, so that I know where to put it. Now, if I substitute something in place of a variable, I have to put parentheses around whatever I substitute in. So I'm going to set up the problem first. 3x minus 8 times something equals 24. Now, the something is what y equals in that top equation, the 5x minus 3. And when I put that into my parentheses, now I have a distribution problem that will then combine with this 3x to equal 24. And again, I have an equation just like before that only has x's, no y's are left. To continue this problem, now my order of operations become really important. I'm going to distribute this minus 8 to both the 5x and to the negative 3. Now, this minus 8 is still just a negative 8 that had something put in front of it. So don't forget that minus sign to take it through as a negative sign. Write down your 3x, and then negative 8 times 5x is negative 40x. Note that it shows up as minus 40x when I write it down with its negative sign. And then negative 8 times negative 3 gives me positive 24. And when I write that down, it shows up as plus 24. That's how you carry signs through with distribution. Don't forget your equal sign in that 24 on the other side. Really, really important. Now, 3x minus 40x, that gives me negative 37x. When you have opposite signs like this, they do act as subtraction, and whichever sign has the most, you're more negative than you are positive, that means that my answer is going to be negative. Plus 24 equals 24. Now, some of you may have already noticed what's going to happen with this. When I go to isolate my x variable, I'm going to have to subtract this 24 from both sides. Again, I'm undoing addition with subtraction. And I have negative 37x equals 0. Now, this is not a no solution problem. Be very careful with this. There's still an x variable in this problem. That means that I can keep solving for x even though it equals 0, and yes, you have to write the equal 0. You cannot have one side of an equation just suddenly vanish into thin air. You do still have to have it there. Now, this x is times negative 37, so I need to divide by negative 37. Fortunately, because it equals 0, that makes my job rather easy, and now I'm left with x equal to 0. Now, x can equal 0. Don't let anyone fool you and say that it can't. It can equal 0. Now, I'm going to scroll back up here and scoot this off to the side a bit so you can see me finish up this problem. I am actually going to take the 0 that I had previously. I'm going to put that in place of x and remind myself that I still have a y value to solve for. I'm going to use the equation where I had solved for y originally and write y equals 5 times something minus 3. Now my something is that 0 for x. 5 times 0 is 0 minus 3, which means that y equals negative 3. If you have 0 minus a number, then you just have the negative of that number. And that completes my point. Based on the length of this problem compared to the first, you can see exactly why I said that it's really nice when they're already solved for y. Now this last problem. This last problem is slightly more complicated, but not really all that much more complicated. And I'm just going to begin this one to show you how you would work through this if you don't already have a variable that you can isolate easily. What I look for is an equation where I could divide by a coefficient in front of one of my variables very easily. 8 can't really be divided by 3, and 3 can't really be divided by 8 very easily. It can happen, but you would get fractions, and I find that inconvenient. Now in this equation, I'm going to pull this one down, rewrite it just so I have a little bit more space, and so that I remember it's the one that I was messing with. I could easily solve for y because all three of these numbers are divisible by 2. And that's exactly my plan. In order to undo a minus 10x, I'm going to add it to both sides of my equal sign. And remember, an x and a number without x cannot be combined, so I have to write this out as 2y, being all I have left on this side, equals 10x plus 38. Now, do I have to write the 10x in front? No. I could write 38 plus 10x and it would be just as correct. Now the only thing I have left to get y equals is to divide everything by 2, and I do mean everything. Remember, multiplication and division are distributable. That means that when you have to do that to both sides, you literally have to do that to everything on both sides, the entire thing. This division by 2 has to be distributed to the 10x and to the 38. And this leaves me with y equal to 5x plus 19. Now this could replace the y up here, and then I could keep on solving. Now, am I done with this problem? By no means. But I'm going to leave this one for you to finish up.